Good morning Year 6, it's time for your math lesson today, and just like the previous lesson we are looking over some fractions work that we did just before Christmas, and today we are learning to multiply fractions, something that we were all pretty strong at, but it's always a good idea to recap this because the procedure is quite straightforward. Sometimes it's the understanding why we do that procedure that can be harder to understand, and obviously it's important to be able to do the procedure, but really it's more important to have that understanding of why we actually do the procedure, why we actually do the things we do to solve that calculation. So that's what we're learning today, to multiply fractions. So if we were to have a look at this question here, we've got a quarter multiplied by 2/5. Now the way to work this out procedurally is to multiply the numerators together and to multiply the denominators together. So if we were to do that, 1 times by 2 is 2, 4 times by 5 is 20, 2 over 20. We can see that, we can all work that out, that's the correct answer. But just to show procedurally why we do that. So I've got two different colours here, I've got pink and I've got blue. So I'm going to represent this 1/4 here in pink. And if we have a look at this grid that I've drawn here, now if you ignore the lines that are going horizontally for now and just look at these ones vertically, you can see I've split it into 4. 1, 2, 3, 4. Just like this denominator here. So it's been split up into 4. 1, 2, 3, 4. Now if I was to represent this 1/4, I would shade in one of these 4. So I'll do that. So you can see there that I've shaded in 1/4 of this shape. This has been split into 4, I've shaded one of them. Now with the blue, if we look at these lines going across horizontally now, you can see it's been split up into 5. 1, 2, 3, 4, 5. This shape has been split up into 5. 1, 2, 3, 4, 5. Now this is 2/5, isn't it? So I'll be shading in 2 of the fifths. 1, 2, 3, 4, 5. I'll be shading in 2 of them. So I use the blue for this, and you can see that I've shaded in 1, 2 fifths of this shape. Now you can see that the pink and the blue have overlapped in 2 separate squares here. 1, 2. These ones don't overlap here with pink, and these ones don't overlap with the blue. 2 of them overlap with each other. That's how we got to this numerator of 2. The denominator of 20 is because the whole has been split up into 20 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is how we got to that answer, showing it visually, how we got to that. Procedurally, it's really straightforward, isn't it? It's multiply the numerators, multiply the denominators. But drawing this helps to prove why that is the case. It's 2 over 20 because they cross over. So if you have a quarter and you multiply it by 2/5, it gets to 2 over 20. And we know that that can be simplified as well, can't we, to a tenth. So that is how we get to that answer. So let's have a go at solving one without drawing that. So if we have 4/7 and we times by 1/3. So I could draw out a big grid here now with 7 down and 3 across, shading 4, then shading 1, and see how many cross over. But procedurally it's far more straightforward, isn't it, to do 4 times 1, which is 4, and then 7 times 3, which is 21. Okay, have a look at this. Can this be simplified? Well, this is an odd number, so we definitely can't do the halving method. Is there a number that goes into the 4 times tables and the 21 times tables? That there isn't, except 1. So this is the answer in its simplest form. So can you have a go at this one for me, Year 6? We will have 5/9 times by 4/10. So could you have a go at that one for me? I might have to pause the video there whilst you're doing that, Year 6. Okay, so let's have a go at solving this. So 5 times 4 is 20. 9 times 10 is 90. If you got to that answer, fantastic, that's the right answer. Can that answer be simplified though? Now they're both even numbers and they're both multiples of 10, aren't they? So we definitely can. Now what we could do at this point, we could use that halving method because they're both even numbers and get down to 10 and to 45. However, that is definitely not the most efficient method to do this. So there is a number that goes into both of these, and it's 10, isn't it? So if we divide both by 10, 20 divided by 10 gets us to 2, 90 divided by 10 gets us to 9. So this is the answer in its simplest form. Okay, so multiplying fractions by another fraction, not really too tricky, but like I mentioned at the start of this, it's important that you do have an understanding of this, because going forward into high school is definitely something you will be doing. So let's have a go one more before we look at something slightly different. Okay, let's have a look at 6 eighths times by 3 elevenths. So you pause the video there, year 6, see if you can have a go at solving this. Okay, so remember multiplying the numerators, multiplying the denominators. So 6 times by 3 is 18, 8 times by 11 is 88. If you got this to the answer, fantastic, you've got it correct. However, it's nice to simplify the answers, isn't it? To show the answers in its simplest form. Remembering that answers in its simplest form are still equivalent fractions, they're still the same size, they're just simplified. So they're both even numbers, so we can use that method of halving, can't we? So let's do that, because both these numbers are a bit trickier to work with than the previous one. So let's do that. So half of 18 is 9, half of 88 is 44. Now let's have a look at these two numbers. We can't do the halving method again now, because this 9 is an odd number. So we need to have a think, can we divide any of these numbers by the same number? The factors of 9 are 1, 3 and 9. We can't divide this by 9, we can't divide it by 3, we can't divide it by, if we divide it by 1 it'll be the same. So 9 over 44 is in its simplest form. Okay, remembering that these two are identical to each other. So multiplying a fraction by a fraction, we've just looked at. So let's have a look now if we multiply a fraction by a whole number or an integer. Remember, an integer is just the correct mathematical term for a whole number. So 4/5 multiplied by 3, and I've represented this in 3 bar models here. Each one of these bar models represents 4/5. You can see it's been split up into 5. 1, 2, 3, 4, 5, and I've shaded 4 of them in, and all 3 of these are identical. And the reason why I've drawn 3 of them is because we're multiplying it by 3. So we've got 4/5 once, twice, 3 times. That's why we're timesing it by 3. Now when you get a question like this, a fraction multiplied by an integer, and remember it could be written just like that. They're both identical questions, both exactly the same. We can work this out. And remember, the procedure to do this is to multiply the numerator by the whole number. 4 times by 3 is 12, and it's been split up into 5 parts, so the denominator will stay as 5. So we can then simplify this by seeing how many 5s go into 12. It goes in twice, takes us to 10, and then there are 2 left. 2/5. They're identical to each other. Now what you can do at this point, if you like using this method that we've looked at previously here, what you could do when you get a question like this is to change this 3 or whatever your integer is and change it into an improper fraction. So put that as the numerator and put 1 underneath. Remembering that 3/1 is identical to 3, isn't it? How many 1s go into 3? 3. So they're identical, and that way it turns it into the same procedure as we looked at earlier, by multiplying the numerators and multiplying the denominators. And if we do that, 4 times 3 gets us to 12, 5 times 1 gets us to 5. So you can see it's identical to that other method that we've done. Now, whilst we've got these bar models, we can also count can't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see it is 12 fifths. 12 of these have been split up to 5. There are 12 of them here. And if we were to count, you can see it's been simplified here. If we were to take this one out and fill it in there, that fifth, and if we were to take that fifth out and fill it in there, you can see that we've got 2 full ones represented here, and there are 2 fifths left. That's how we got that simplified, and it shows it really nicely in a visual way. So could you have a go then for me, please, Year 6, at doing 4 times 3 sevenths. So remembering the procedure is multiplying the numerator, or you could do that. So could you have a go at solving that one for me, please, Year 6? Okay, so 4 times by 3 gets us to 12 again. 1 times by 7, or you could have just moved the denominator over to 12 over 7, which is a perfectly acceptable answer. Let's simplify it though. How many 7s go into 12? There is 1, and there are 5 left over, and the denominator stays as 7, because that's how many parts the whole has been split up into. So we'll do 2 more, and then you can have a go at these yourself. So let's do 3 eighths multiplied by 8. Could you have a go at that one for me? Okay, so let's try it without turning this into an improper fraction by doing 3 times by 8 turns us to 24, and then bringing the denominator over to 24 over 8, which is a perfect answer. We can simplify it though by seeing how many times 8 goes into 24. 8, 16, 24. It goes in perfectly with nothing left. So these two answers are identical to each other, 24 over 8 or 3. Right, we'll do one more than Year 6, and you can have a go at these yourself. So let's do 11 times by 4 over 10. Could you have a go at that one? Okay, so you could have done this. So 11 times by 4 is 44. 1 times by 10, or just moving the 10 over, depending which way you prefer, is 10. That answer is perfect. Let's simplify it. How many 10s go into 44? It takes us up to 40, so there are 4, and there are 4 left. Denominator stays as 10. These two answers are identical to each other. This can be simplified, can't it though, using that method of halving and halving again. So let's halve the fraction to 2 fifths, half the 4 to 2, half the 10 to 5. Now remember, we don't halve the whole number though, the whole number stays as 4. So these three answers, 44 over 10, 4 and 4 tenths, and 4 and 2 fifths, remember they are all identical to each other. They're just 3 different ways of representing the same thing. This is the fraction in its simplest form. This is when it's improper. This has been simplified once, and this is in its simplest form. Okay, Year 6, so could you have a go at the sheet that's attached to this on Google Classroom with these multiplications, remembering to simplify the fractions if possible.